Perfect. Thank you, Mark. Good morning, good afternoon, or good evening, everyone. Welcome to my session on Python, how it fits into SQL Server 2017 and 2019. And because we're the hybrid user group, we'll also talk a little bit about where we can use it in Azure as well. So this is me. I'm an independent BI consultant, splitting my time between Albuquerque, New Mexico, and the Dallas, Texas area. I've been doing the SQL stuff quite a while, as you can see. But the important piece to know on this slide is down in the bottom right. If you like the session, tweet at me, tweet at everyone you know, let everyone know how good it is. If you don't like the session, if there's something you think I could do better next time, or even if you just have a question later, well, that's what the email listed is for. So here's what we're going to talk about today. There'll be a brief warning, and I'll give an overview then of how Python fits into the SQL ecosystem. And I'm going to go under the assumption that most of you might not have had a chance to play with this integration yet. So I'll show you how to do the installation and configuration really quickly. Then we'll go into our first demo, which is how to get data into and out of Python from our SQL ecosystem, really without leaving SQL at all. And we'll do that using a stored procedure called SP-execute external script. And you'll hear me say that string about a dozen times or more during the next hour. And after that, I'm going to look at a couple of real-world use cases. Now, I know we've got kind of a more global audience, and my use cases here are focused on the US healthcare system, which is a little different than the healthcare systems in the other parts of the world. But I've tried to make the examples, fairly generic so that they can spark some ideas in you how you might use this stuff going forward. So I hope you all were ready for this. You've come to a Python session willingly. Python is really good at computation, at statistics, machine learning, all of which depends very heavily on math. So I'm not putting this up here to scare too many people, but I do want to get it out of the way first, make sure everyone understands what they're getting into. So Python is part of a larger piece called machine learning services. And this came about because Microsoft realized, hey, we need to go beyond our traditional relational database, SQL Server. We need to get into the wider analytics world. And that's increasingly an open source proposition. Now, they acquired a company called Revolution Analytics out of New Zealand that had focused on R. And they had a couple packages to help R do some things well that R doesn't do natively very well, just spill data to disk and multi-threading. And actually, base Python doesn't do those things well either. But because they built those extensions, they were kind of a natural fit for Microsoft to acquire and to roll into the 2016 version of the product. Now, the 2017 version rolls around. They decided to get Revolution to build some additional extensions for Python. They rolled that in, and now it's machine learning services encompassing both R and Python. And in 2019, it actually encompasses Java as well. And it's not just any old Python, it's a very specific distribution called Anaconda by a company called Anaconda out of Austin, Texas. And it's a distribution that's focused specifically on data science. And it comes with more than 100 of the most popular packages for data science already built in. So when you go through the install, everything you need will be right there ready for you. And it also comes with a package manager called Conda that allows you to add or update any additional packages that you may need. Now, it is Python version 3.5. It's not the latest and greatest. I think 3.9 is out in the wild, but that shouldn't be too much of an issue. You may have some minor compatibility issues in some of your packages, so you'll probably want to make sure that any developing you're doing, if you're doing it in a separate Python ecosystem, that you're also developing in Python 3.5. One difference I don't have on the slide, that this is now available, this integration is available in public preview in Azure SQL Managed Instance. And in that case, it's actually Python 3.7. So slight difference there. And this install also comes with a great tool called the Jupyter Notebook. Now, I hope that most of us have had a chance to play with notebooks by this point, but if you haven't, don't worry. Just know that it's a tool that allows you to put all of your code together, all your scripting, along with any data. So it might be data that you've created, data that you've brought in from a text file or a database, and then any data that you create as an output, or any graphs or charts you create as an output. It saves all of these along with any markup in a single document that you can spread around with the rest of your team so that they can reproduce your work. They can see how you got to the conclusions that you came to. We'll see that more in our second big demo here in a little while. So I mentioned that we have about 100 data science packages that come installed with Anaconda. So these are the 5 most important that we'll start with. We'll actually only look at 4 of these today. We'll be looking at NumPy, which gives us multidimensional arrays. It gives us a lot of numerical manipulation. And it also serves as the underlying basis for pandas, which is short for panel data. It has nothing to do with cute but vicious fuzzy creatures. So panel data or tabular data. It gives us an object called the data frame that is the closest equivalent to what we would think of as a SQL table. We'll also look today at SciPy, which gives us scientific computing. It gives us access to a lot of methods around known statistics. What we won't look at today is scikit-learn. Really, an intro, excuse me, an intro to machine learning would be a whole separate session. So we won't be touching that today, but if you like what you're seeing, if you're interested to try it out and you want to take this into the machine learning realm, then scikit-learn will be kind of your first port of call there. And then we'll also look at some simple graphs today done in just a very few lines of code with Matplotlib. It's a great way to get pretty professional looking graphics very, very quickly and easily. So this is the installation screen that's part of the normal SQL install. And you'll see I've got circled here machine learning services in database. This is what allows us to use the integration that I mentioned. And you'll note that you can choose R or Python or both. They play nicely together. But you'll also see down below, you have machine learning server standalone. And that's not what we're going to talk about today. That's really in the instance where you have a team of dedicated data scientists and you want to help them leverage the extra pieces that Revolution Analytics built in. You would set up this server for them and kind of let them have at it. But again, everything we're going to look at today is this in-database machine learning services. And that will give us a brand new service called the SQL Server Launchpad. We'll look at that in more detail in a few slides. I've got an architectural diagram coming up. Just know that if you see that service pop up, it's to do with machine learning services. So there's a couple things that you'll want to do after you've got this install set up. So first off, what we're going to be doing is actually running some Python code on our machine. That's not too dissimilar from if you've used CLRs, the common language runtime, how that runs C# code on your machine. But what if you have a bad actor that's writing malicious Python code? Well, it's easy enough to secure that, make sure that doesn't happen. But just an additional step is even though we've done the install, it's not enabled by default. So we have to actually run this reconfiguration to turn on our SP execute external scripts procedure. And then after we've done that reconfigure, we'll need to restart the Launchpad service to make sure that everything takes effect. The other thing that's a little bit different, and if I go back to the dark days when I was a DBA, so apologies to any DBAs on the call, except for Mark. No apologies for him. But I would get a new server, and I'd maybe give 85, 90% of the memory on the box to the SQL process and let the operating system take the rest. But in this case, I'm going to have to save any memory that I'm going to, the data sets that I'm going to analyze. I have to save that memory aside in RAM as well. So the marketing spiel for this is they call it in-database analytics. I call it in-database analytics with the air quotes because it's not true in-database. Your data does leave your database and it gets copied into RAM for Python to act on it. But it does so very, very efficiently, which is kind of your main benefit to putting this on, say, the same box as your data warehouse, but you are actually making a copy. So the data doesn't stay in database, even though to you, you haven't left your SQL environment. So because of that, you'll want to save that extra memory. It's outside the SQL Server buffer pool. Just set it aside. And that will depend completely on your workload. Everything I'm doing today is, it's a fairly small set of data. I've got my sample data warehouse, but I'm summarizing the data in there before I send it over to Python to work on. So I'm really not working on very large sets of data. However, if I was going to send 100 million rows over to do some machine learning, supervised or unsupervised against, I would really want to have that RAM set aside for that much data. So just like anything else in the SQL environment, you have to really know your workload or your intended workload. I mentioned the package manager. So it's called Conda. So you can go into a command line if you want a new package that's not part of the 100, say PyODBC in this case. That's one of the more popular Python ODBC libraries. So I just type in conda install PyODBC. It will go out and find the most up-to-date version and install it to my server. You've got another option that I'm not going to show you today called SQL ML-utils. That's a command line option that enables for you to do this from a client. So obviously you would, if we were working on the managed instance, we don't have access to the operating system on an Azure SQL MI, so we would need to use that SQL ML-utils, or more recently, they've built a graphical extension to SQL ML-utils that lives in Azure Data Studio that you can also use to interact with Azure SQL MI. So let's go ahead and jump into our first demo. I'm going to show how to get data back and forth between SQL and Python. So I'm going to jump over into Management Studio over here. And I'm going to introduce you to SP-execute external script. And I'm kind of contractually obligated to first off do a hello world. So we're going to pass in a number of different procedures to our SP-execute external script. We'll start off with our language being Python. And our script will be the Python code that's going to run in Python. And here we've just got a simple print statement. So let's go ahead and run that. And there we go. But we want to do more than just print in Python, right? So let's figure out how to send some data over from our SQL system into Python. And for the first thing we're going to do, we're just going to get the same set of data right back. Let's make sure we can pass it over. So what are we going to pass over? Well, we're going to pass over the results of a query. So in this case here, I've got a tally table. Go ahead and move my windows here. I've got a tally table in my admin database. I'm just going to select the top 10 numbers. That's just a table of sequential numbers for anyone who's not familiar with the term tally table. I'm going to just select those. And that query goes into my input data1 variable. And the results of that, the engine sends, and Python puts them into a variable called input dataset. I've just got another variable output dataset. I'm going to send those results straight back to SQL. So let's go ahead and run that. And then we've sent these numbers over to Python and we're getting them back. But we're kind of using these default input data set and output data set here. I don't care for those too much. So what I'm going to do, instead of input data set, I'm going to call it my query. That helps me remember, hey, these are the results of the SQL query that I ran. Well, to do that, we just need this additional parameter, input data one name, to say that my query is going to be the name of our input data set. And so it shouldn't be much of a surprise that we can do the same thing with output data set. Now I'm going to call it results. Just helps me remember that these are the results of my Python script. And we just have to add output data one name. So at this point, you might see these underscore ones, and you might think that implies, oh, you can have underscore 2, underscore 3, and so forth. But unfortunately, you can't. It's just one data set in, one data set out. If you do need to send multiple data sets in, you'll have to go through some type of workaround. Feel free to connect with me later if you want more details about that. That's not included in the presentation today. I just wanted to make sure that you knew this underscore 1 did not imply multiple data sets. Hopefully it implies that's something they're thinking about for the future and they've left some room, but we'll see how that goes. So let me just demonstrate that this still works even with our new aliases. Perfect. All right, so this is a pretty simple query, right? This is just a one-liner, but in the demos we'll get into, we're going to see some much longer queries like you would see in the real world. In fact, I think the second use case, our query is about 150 lines. So I really don't want to embed a 150-line query in the middle of a procedure call. That would just be hideous. What I want to do instead is add an additional variable, input query, and I will just paste a nicely formatted query in here. Now, I've probably worked on this in another query window. It's ready to be operationalized. So I'm going to drop it into my input query variable, nicely formatted, much easier to read, to understand, and to debug. And so I just drop that variable. I pass that into my input data one instead of the string with the query name. And similarly with the Python script, I'm going to pass in a variable here called PyScript, which is just the simple version of my Python code that I've developed in a Python IDE or a notebook somewhere, and I'm ready to put this into operation. So now you can see we've got a very clean procedure call, and any business logic or the coding logic that we need to include in either our query or our Python code, it's abstracted out from the procedure call. It's much, much cleaner this way. Let's show it's still running. Perfect. So I hope this piece kind of serves as a good template for a lot of you as you start playing with this in your own environments. But obviously, we want to do more than just get back exactly the same data we send over. So let's start with a simple manipulation. So instead of sending the data back, we'll do kind of the most simple statistical manipulation that I could think of, which is to take the standard deviation of the numbers that I'm passing in. So let's go ahead and run this. And if you've got good eyes, you may know what's about to happen, which is a whole wall of red text. Now this is a really good error because it comes with this little attached scroll bar on the side. Now, I will say when I was working on this script, a version of this script in R, these error messages were arcane. They were almost impossible to understand. The Python ones are much better. You just have to be able to find the salient line, which is this one right here. Our standard deviation function isn't defined because our standard deviation function is not in base Python. It's actually in the NumPy package. So we're going to have to tell Python, hey, use that NumPy package And we do that by using the import command. And then pretty much anywhere where you see NumPy being used in the wild, you will see it being aliased as NP. So this works in a similar way to kind of an alias in SQL Server, except instead of table alias.column, we've got package alias.method. So let's give this a try. And we've got another wall of red text. So what's going on here? Well, it's telling us our results need to be a pandas data frame. So everything that we send over to Python gets put into one of these pandas data frames by default, but it also needs to be in a pandas data frame on its way back to SPExecute external script. Now what we've done here is we've just taken the standard deviation, which has turned our column of data in our data frame into a single floating point number. So we need to turn that into a data frame, even though because it's only one number, it's just going to be a data frame that's just one column by one row. It still needs to be that data frame. So to do that, we're going to import the pandas library. And the standard abbreviation for that is PD. So pd.dataframe sets up a new data frame for us. So if I was to take this out, pd.dataframe and empty parentheses would just give us a completely empty data frame. But if we pass anything into it, that will just coerce that into a data frame. And then we will be able to run our SPExecute external script and get our standard deviation back. And there we go. All right, let's move on a little bit and skip a couple of queries here. And let's look at a more interesting set of data. I'm going to kick this off first and then explain it. So this is the iris data set. This is one of the most famous data sets in data science. It's the one everybody starts with when they look at machine learning because it's got the petals and the lengths and widths of petals and sepals of different species of iris and which species it is. And you can use that to set up a model that will very accurately predict from the ratio of those numbers what species an iris is. If you've got an iris but you don't know what type it is, just measure the petals and the sepals and plug them in. Okay, now that took a few seconds. Now the reason it did that is this is coming from this PyDataset library. More specifically, this data portion of the PyDataset library that's got another 750 data sets over and above the iris data set. Now, unfortunately, we had to bring all of them in just to use the one. So let's see what that looks like. Oh, okay, well, another error, but at least it's only 2 lines of red text this time. And this is actually pointing us specifically to the with result sets clause. Now, this was something that I believe this was introduced in SQL 2012, but I never had to use it until I started playing with machine learning services. But what this clause does is it allows us to rename, redefine the results of a stored procedure execution. But in this case, we've just been using this one default on all of our examples so far. We just had 1 column worth of data. But the iris data set actually has 5 different columns of data. So we need to change that with result sets clause here. Let's go ahead and kick this off again. We need to change that to make sure that we've given all 5 columns names and then data types. And note that these are SQL data types, not Python data types. So this is how SPExecute SQL is going to interpret the data that it's getting back from the set. So let's give this 10 more seconds. And there we go. So all the data we could ever want about irises. So this script, it seems pretty simple, but between the R and Python versions of developing it, to get to this point took me about 4 to 6 hours. So if I could save that much time for everybody that's on the call today, that's at least 2 weeks worth of person work. So that's pretty well worth it for my 60 to 75 minutes today. So I'll give you all a GitHub link to it. I don't know if Mark can also share it on the hybrid.pass.org, but I'll make sure you all have access to the script so that you can use it when you start playing with the Python integration as well. All right, let's jump back over to our slide deck and take a look here. This is what the architecture looks like behind the scenes. We've got our SQL Server process here on the left. Now we have some SQL code that calls sp execute external script. So that fires off the Launchpad service. The Launchpad service starts the Python launcher DLL, which instantiates a new Python process for us. But it also instantiates this thing on the right called the BXL server. And that stands for binary exchange language. Now that's the process that is passing data back and forth between Python and SQL Server. And it does it right at the TCP/IP level, very low level, even a lower level than an ODBC connection. So it's very, very efficient. So this is kind of your main reason to put this integration on the same server. You don't need an ODBC call to go get the data from another server. It can pass it back and forth very, very efficiently. This saves us a lot of time in data transfer. So this is the key. So any questions about the setup, please ask me a little bit later. So we've covered, that was probably about the first half of the presentation. We've spent all that time covering the how. So the more important piece is the why. So I'm going to give you a couple examples from my consulting career. As I said earlier, I focus a lot on healthcare in the US market. So some of these examples may not directly translate to you if you work in healthcare in a different market. But I hope these examples should still be applicable to you all. And because I don't want to name the companies I could name or shame the one I could shame, let me introduce you to my fictional hospital, where all the doctors magically look like famous Hollywood actors. So we have a couple of problems here at my fictional hospital. So let's start out with the first one. So you're going to be on your honor system for this piece. If you're a report writer, raise your hand. If you've been a report writer in your past career, raise your hand. Heck, even if you've written a report that's gone to production, raise your hand. Now leave your hand up if a report that you've created has ever caused panic. So that's exactly what we've got here at my fictional hospital. So I've got an SSRS report. I'm going to head on over to SSRS and take a look at it. So we have a charge summary report. And see, we could limit it to, say, just part of our organization or even to a specific doctor, but we'll just run it for everybody. We'll look back at the last 30 days worth of charges, or the bills that are going out the door to be paid by a combination of the patient and their insurance company. So here's our report that our clinic administrators have run. And they look at this blue bar on the right for yesterday's charges, and they see, wow, we had a huge drop off between Tuesday and Wednesday. We must have a real problem. Maybe our charges aren't going out of the door. Maybe we're not, going to make the money that we think we're going to make. So there's a big panic. They call me immediately, or they put in a critical help desk ticket. But there's not really a problem here. I know that because I've brought the last 180 days worth of charges into Python and done a quick histogram with a few lines of code. And so I see that our historical charges, they fit this bell curve that we may be familiar with, or what's probably called the normal distribution. And looking at this, I can infer a couple of things. So one, it's a normal curve with just a single hump. So it's really just normal day-to-day variation. It's not going crazy. There's not a lot of wild things going on, just normal, everyday, expected variation. And I can also, some of that math I warned you about, I can also infer the magnitude of that variation. So let's say we look at the example in the bottom left here. 95% of our data, when it fits that normal distribution, fits within +2 and -2 standard deviations from the mean. And it's symmetrical. So the 5% that doesn't fit is 2.5% above, 2.5% below, or 1 day. Excuse me, or 1 day out of 40. So what I can do, I can put some lines on my bar chart at those points. So it's a technique from my old manufacturing days called control lines. So we can put those on there, and then our clinic managers can look, they can read, is the value between those lines? Yes, okay, we're good to go. Now I could get really tricky here, but let's just stick to the ±2 standard deviations for this example. Okay, so now all I need to do is code this bad boy in T-SQL. Okay, that looks pretty hideous. You know what? I know Python is good with statistics, so let's do it in there. So I'm going to hop back over to Management Studio. Move my windows around. So here's a little bit of context. And we've got, this is the existing procedure that allows us to bring back the data for the report as it is. So we've got the 4 parameters that you saw me pass in. And this is pretty simple. It's just going to the fact table in our data warehouse. And it's summing up one of the measures in our fact table. And then I'm joining in my dimension tables. And then I'm filtering the members of those dimension tables based on the parameters that I'm passing in. So if you've written a report, or particularly if you've written a report against a data warehouse, you've written something that looks a lot like this. So I'm going to leave that, but I'll add a second procedure alongside it just to bring back the statistics. So we'll use 3 of the same 4 parameters. Now I'm not going to use the number of days to look back, because the user might run this just for, say, 7 days, and that's not enough data to be statistically significant. It won't give us a good view. So I'm going to hard code this to the same 180 days that we looked at in our histogram. But this next part is pretty similar. We're going to sum up one of the measures from our fact table, again, joining and filtering our dimensions based on the parameters so we get down to the grain we want. So one little wrinkle here, so I'm casting this as a float, and that looks a little bit weird to most of us, but I'm doing that because Python does not understand SQL, fixed precision numerical data types. So my charges are a decimal 12,2 in my data warehouse, but if I send that into Python, it's going to choke on a data type that it doesn't understand. So that one took me a little while to figure out as well. The solution, as strange as it may seem, is to cast this into a that slightly less precise data type, but it's one that Python can understand. So this is another gotcha that will probably catch some of you out as you go through and develop this. But so I'm going to cast that into there. Now here I'm going to put total daily charges. I'm going to put them into a temp table. Now, this is not something that I would do in production. I'm just doing this for demo purposes so that my input query variable here is nice and clean and fits on one page. So in production, what I would do is actually have this, say, 50, 60 line query, and I'd put that into my input query variable. But it would be difficult to show that in the demo. So just going to put that here. Hope it's clear to everyone. This is kind of a do as I say, not as I'm doing right now situation. I'm doing that. I'm going to point out a couple things here. So one thing that we've got here is, we're filtering out Saturdays and Sundays. Okay, why are we doing that? Well, we're doing that because I told you a little bit of a white lie. I said this was my fictional hospital, but it's really my fictional ambulatory clinic or an outpatient clinic. But that doesn't sound quite as good, and I couldn't fit it into the slide very well. But because we're an outpatient clinic, we're closed on Sundays. That's the gaps between these bars here. And the very small bars, that's our Saturday. The only thing we have open is our urgent care. So if I leave that data in there, then our mean would be right through about here, and it would be great. We're above the mean on 100% of the work. Okay. So, that would show up, and that would be pretty obvious. What would not be so obvious is this next part, but it's related. But, in the last 180 days, actually probably just outside of our window now, but, Christmas was a Wednesday. New Year's Day was a Wednesday. We were closed on those days. So we've got to filter those out as well. So I do this to kind of illustrate a point. There's a famous diagram by Drew Conway, and it's a Venn diagram of 3 intersecting circles, where he says that data science is the intersection of one circle is hacking skills, which in our case is, can we query our database? Can we write Python code to manipulate that? And it's intersected with statistical knowledge. And that's, in this case, we know that our data fits a bell curve. We know what that implies. But the third piece, and just as important as the other two, is the bottom circle that he calls substantive expertise, or you may see that listed as domain knowledge in some places. That's the knowledge about our business. That's, without that, it's just empty data. We really need to apply the knowledge of our business to turn that data into useful information. Okay, so now we've got that. That's our query. That's our data set that we're going to send over to Python. Now, I want to point out, as we scroll through this query, you can see I'm pretty liberal with white space, and I'm pretty standardized on having everything tabbed over from my begin, my stored procedure. I'm very picky that way. And then we come down to our Python code, and everything suddenly is left justified. So that's deliberate. The reason for that is where T-SQL, the SQL engine, takes that white space and pretty much ignores it. That white space is actually meaningful to Python. So if I write a while loop in T-SQL, I've got a begin and an end, and everything between those two is what I'm iterating through based on the while condition. Python doesn't have that begin and the end construct. You've got a condition, and then you tab over from that. And everything that's tabbed over, Python knows that's the loop that I'm going to iterate through. Those are all the commands that I'm going to repeat. So if I throw a tab in here, say I go up here and throw in this tab, well, Python's going to see that, and it's going to return an unexpected character error because there's no controller for the looping mechanism. It's just going to see a tab that is completely out of context. So that's another gotcha that you might run into. That's why we've got it tabbed over here. So you'll see this is a simple Python snippet. It's just 5 lines of code. The first 2 are just to import the libraries that we'll need. This next line of code, we're going to create a list. Now, a list is just a Python collection of data, and it's denoted by these square brackets here. And we're going to have 4 items in our list. We're going to have the mean, the standard deviation, the mean +2, and the mean -2. Okay, we've got our data, but we know that we need to turn that list into a data frame so that SP-execute external script can understand the data coming back. So we'll turn it into a data frame. But unfortunately, at this point, it's put that one list into a column. So we've got one column with 4 different rows. What we really want here is one row with 4 different columns. So we've got to do a non-pivot. So how many of you have written a pivot or an unpivot in T-SQL? So don't you wish it was as easy as saying just .t? So that's the transposition. That just flips the axes on our data frame. It's not a true pivot or unpivot because we're not summing up any data, but it is very, very, very cool to just be able to do that that quickly. So now we've got our data frame. It's one row of 4 columns wide like we want. Hey, we've got a nice clean procedure call here, cleaning up our temp table. So let's see what the report that's using that looks like. So let's go ahead and kick it off. We can see in our report definition here that we've added that charge statistics data set. And we're going to set the black line equal to the mean, the green line equal to mean +2, the red line equal to mean -2. Let's go back over to Reporting Studios while it's running here. So I apologize for the slowdown. As you can see, my GoToMeeting process is eating a heck of a lot of my CPU on this ancient laptop. Okay, so now those control lines are in place, and we can see that our clinic managers, they don't have to worry about everything. Our charges yesterday, they're within this normal day-to-day variation. Now those clinic managers, they don't care about statistics or standard deviations. They just want a way, show me when it's good, show me when it's bad. So we've taken this tool they were already using, this SSRS report. We've used our knowledge of statistics, our knowledge of hacking through our in-database machine learning services integration. We've been able to give them an extra way to understand the data that they're looking at very, very easily. So a couple final points on this. The green line is here. Well, why is that even there? Wouldn't it be great if our charges were way up here? Well, it really wouldn't. I mean, that bell curve is symmetrical for a reason. You can't have your cake and eat it too. If our charges were way up here, that's the point at which I, as the developer, would panic, because that may mean I've got a duplication occurring in my report procedure, or maybe there's something going on with the ETL, putting the data in my data warehouse. Either way, it's just not normal to have the data up here unless I know there's a reason, like maybe we opened a new clinic, that would be an explained reason why everything jumped up. But if we don't have that, no good. So it's got to be between both sets of lines. So the other point, I've got a second white lie to admit to. I implied that we would need to code this ugly mess in T-SQL. We really wouldn't. We do have an stdef function in T-SQL. I just wanted to start us off with a simple example so you can see how we're doing this statistical integration. Because this next example that I'm going to give, there's no way we could code that in T-SQL. So our second problem at my fictional ambulatory clinic, it's our patients. More specifically, it's that sometimes they just don't show up. So I've got a report to show the magnitude of that. But I got to admit, I've been guilty of this before myself. I make an appointment with my GP or my primary doctor, and I can't get an appointment right away. Feeling sick, I can't get an appointment for 3 days, but then I'm feeling better by the time that third day rolls around. But I forget to call and cancel my appointment. So what that leads us to, the doctor's, sitting idle in their clinic. So if we look at the support, so we see Bones here, he's a cardiologist. And you don't skip too many of your cardiology appointments, right? So he's got a 10% no-show rate. But Dr. Quinn, medicine woman, is a family GP. Nearly 25% of her patients don't show up. So out of her 32 patients a day, that's 8 patients at 15 minutes per that they're not coming into the office. So she's actually idle for a couple hours a day. Well, we need to change that. So the first thing we might think of doing is booking an extra 8 patients a day, or overbooking 8 patients. And that sounds good, except then you have those days where 30 out of your 32 patients show up, plus the 8 that you've overbooked. So now you have 6 patients too many, and at that 15 minutes per, that last patient has been sitting around in our waiting room for 90 minutes. Now they're going to get upset, and they're going to not come back to our practice. They're going to change to a different set of clinics. We don't want that to happen. Yeah, we wanted to maximize our revenue by maximizing the number of patients we see. We end up minimizing it in the long run because so many patients leave our practice and go to a different one. So what we want to do is find that magic point to where we can overbook without overbooking. So this is applicable to a lot of other industries. It's applicable to the hotel industry. It's applicable to the airline industry. But famously here in the States, you have United Airlines where they bopped somebody on the head and dragged them off the plane. Now we can't do that in our waiting rooms. And if we could, I'd sign up for it. But we've got to find that magic point to where we can overbook without overbooking. So to do that, we're going to use this tool called the Galton board. You may have seen this before in a science museum or the Plinko game on certain versions of The Price is Right on TV. So what we have here, we've got a series of wooden pegs. You drop the ball down at each peg, there's a 50-50 chance of it going left or right. 2 different options gives us the term, after we've sent enough balls through enough rows of pegs, gives us a distribution called the binomial for those 2 choices. And that's analogous to our 2 options here. The patient shows up, the patient doesn't show up. So Pascal figured out all the math for this back in the 17th century. But it's much more fun to actually see it in action. So we've actually got some different math we need to look at too. So at this point, I'm going to head over to my browser and look at one of the Jupyter notebooks. Now again, this Jupyter tool comes with the Anaconda distribution, but I could have used any other notebook. I could have used Azure notebooks or notebooks in Azure Data Studio to do this. I'm just choosing to use Jupyter because that's what comes with my Anaconda install. Now we'll start off here. We're just going to step by step, one cell at a time through each of these. Now this first cell gives us the libraries that we're going to need. But maybe I don't remember exactly what all the methods are that I need. So I can call up help here and I can look down. And I'm noticing right away a lot of the arguments that are being passed into these methods, they're exactly the same for each one. So we can tell that they're all related. Now what we'll look at here, we'll look at the RVS method today. That allows us to generate data that fits a binomial distribution. We'll also look at the probability mass function. What this will do is this will give us an exact percentage of the chance of hitting a specific point on the curve. So let's say that Dr. McCoy, 90% of his patients show up, P equals 0.9. He sees 16 patients a day, N equals 16. What is the chance that exactly 15 of his 16, K equals 15, what's the chance that 15 out of those 16 show up? And related to that, we have the cumulative distribution function, which takes the same arguments, but instead of what's the chance that 15 show up, it's what's the chance that fewer than 15 show up. And then we have this last piece here. This is the percent point function. This is kind of our magic point. What we're going to do as an organization is we will say it's okay to have 1 or 2 extra patients 10% of the time. You know, that's not so many extra patients that they'll get upset if they sit around in the waiting room for 15 minutes or so. So let's find the 90th percentile along that distribution curve. So if we say Q equals 0.9, we'll keep our 90% for Dr. McCoy and his 16 patients. So what's the 90th percentile along that distribution for him? Now it may be fuzzy now, but it'll become a lot clearer when we look at it graphically here in a second. Now I'm going to start off by generating some data, and we'll do it with this other classic example of the binomial distribution, which is flipping a coin. Now, if it's a fair coin, it turns up heads 50% of the time, tails 50% of the time. So a head will be a 1, a tail will be a 0. And analogous to our use case here, a patient showing up would be a 1, a patient no showing would be a 0. But I've got one coin, N equals 1. I'm going to just toss it 5 times. Okay, we get 2 heads, 3 tails. Do it again, 4 heads, 1 tail this time. Well, you know what? Now I've got 10 coins. I'm going to toss all of them together, and I'll add up the number of heads. I'll do that 20 times. You know what? Computer's cheap. I'll do it 1,000 times. And we can see, as we'd expect, a whole lot of 5s, slightly less 4s and 6s. There's 1 10 that's popping out. That's not terribly helpful seeing that, even though kind of the data distribution looks like we might expect. What'll be better for us? Let's do a simple histogram. Now, this is just 4 lines of code based on that data that we've generated. That's pretty good for 4 lines of code, I think. And that gives us the distribution that looks like, what we saw in the video. But this is 50-50. If my patients only show up 50% of the time, I'm not going to be in business very long. So let's change that to 70%. And we can see how it starts skewing to the right. But Dr. McCoy is even more extreme. That was the 10% of his patients don't show up, so 90% do. And out of his 16 patients a day, what does 10,000 days in his career look like? Okay, so we can see it's very skewed. And actually, everybody shows up. This is maybe 18% of the time, and only 1 person doesn't show up, about 1/3 of the time. Now, we said for our business, now I see we're about to hit the top of the hour, so I've got maybe 10 more minutes to go. So if you drop off, I won't be offended. But yeah, if you can stick around for 10 more minutes, I'd love to keep you. We said that it was okay for a business to have 1 or 2 extra patients, maybe 10% of the time. But this is more than 10% of the time. So we're kind of seeing graphically, we can't overbook for Dr. McCoy. If we do, we'll have more patients more than that, threshold. So let's look at some of the numbers to make sure we're doing this right. Let's look at the probability mass function. So this is the example I mentioned earlier. What's the chance that 15 out of 16 of his patients show up? We saw on the histogram, it's about 1/3 of the time. Very, very close to 33%. Now let's use this A-range function. Let's look at all of his percentages. And so, yeah, this is about 18% of the time that all of his patients show up. This is 16 out of 16, 15 out of 16, 14 out of 16, and so forth. But that didn't jive with what I thought I knew about our business. Really, everyone's going to show up 18% of the time. So I needed a way to make sure that I'm doing this right. Now, I'm not a PhD data scientist, but I've got the next best thing, which was I misspent youth playing way too much Dungeons and Dragons. And that gave me a good grasp of basic statistics and probability. And so I know using that the chance of these discrete events occurring, and when I say discrete, I mean whether or not Mr. Smith shows up to his 10 o'clock appointment. There's no bearing on whether Mrs. Torres shows up to her at 10:30. They're completely independent. Because they're discrete like that, I can just multiply that 90% together 16 times. Yeah, it really is 18%. So I show this because when they put machine learning services out there, the marketing spiel was, it's a magic bullet. You don't need to know math. And I'm going to say that's not entirely true. You do need to know some math. I don't think you need to be that PhD statistician, but having a good grasp of basic statistics and probability are really good. It would really help you to check your work, make sure that, if you're not sure about the results you've got, can you reproduce them a different way? So it's super helpful. So the other point here, if you only get one thing from the presentation, I really would like it to be that script I gave you earlier that's going to save you all 4 to 6 hours of work when you start playing with this stuff. But if you get a second thing, you really should be playing more D&D. It's going to be super helpful in your data careers. Anyway, moving on, we're actually going to skip the range percentages, looking at the time. I'll let you play with these on your own. We're going to skip straight to the quantile probability. That's that magic point. That's that 90th percentile of the way along the curve. So if we run this code for Dr. McCoy's 16 patients that show up slightly under 90% of the time, we get 16. That's 16 out of 16. That's what we saw earlier. We can't overbook for Dr. McCoy. But things are very different for family medicine. So if we look at Dr. Quinn's complete percentages, her patients don't show up nearly a quarter of the time. But what that means here, this top left, 32 out of 32, everyone shows up only about 1/100th of 1% of the time. Now 31 out of 32 is about 1/10 of the percent of the time. So really what we want to do, now let's look at this graphically. Let's find that top 10%. Is it in this bar? Is it in this bar? Let's use our percent point function, find out, but it's exactly at 27. So what we're seeing here, we can safely overbook 5 slots for Dr. Quinn every day. Now we're only going to have extra patients sitting around 10% of the days. That works for our business. So this is all well and good, but our clinic managers, they fell asleep, as soon as the video ended. They just want to know, tell me when it's, and in the last one, a quick, tell me how many patients I need to get in. So again, I've got a procedure over here, and we'll skip through, the worst part of our query. I just know that we're basically sending in, in 150 lines here, our historical no-show rate for each provider and the number of patients they have for any given day. And we'll run it through a quick, 7-line Python script, of which 3 lines here. That's just the 2 libraries we've seen before. Plus, we don't need all of SciPy stats. We just need the binomial method. Now we've got our data frame called my query that we've seen based on what we're passing in. We're just going to add a brand new column to it. Expected appointments. We'll initiate it with 0, and then we'll set it equal to the results of that percent point function based on our 90th percentile threshold, based on our number of appointments, based on our historical no-show rate. And we'll get back the number of overbooking slots allowed. send that into a data frame, send it back onto a report. That looks something like this. Now again, we'll run it for, everybody. We'll just run this for next week's appointments. And we will leave in that 90th percentile threshold, even though we'll allow the clinics to better customize that themselves. Maybe they want to drop that down to 0.8. They can get a few extra patients in. The cost of maybe setting a couple extra patients will let them manage that part themselves. So this report will come out, and because of time, I'll summarize it a little bit. We'll see that Dr. McCoy probably has about 14 patients for Monday. We'll see that he won't be able to overbook any based on our percent point function, but we still have 2 empty slots, so our clinic managers need to get 2 people in on the phone. But things will look a little bit different for Dr. Quinn, and hopefully that will return that I can show you here. So Dr. Quinn has 30 patients scheduled for Monday. We'll expect 26% of them to show up based on the percentages. So we can overbook 4, but we still have 2 patients we never booked in the first place. So that's a total of 6 patients that our clinic managers need to get on the phone and get in for Monday. So again, we didn't need to be full-blown data scientists for this. We just needed to have a little bit of statistical knowledge and know how to use our in-database integration of machine learning services to fit that into the tools that we're already using. So I hope that has sparked some ideas of how you can start using this. So this is the last slide here. These are some resources. So starting off is my GitHub. This presentation is up there along with the slide deck, all the Python code, and all the SQL code needed to set up a dummy warehouse that has these same characteristics. And then if you want to go further, Microsoft's got a great tutorial, or start looking into the MOOCs, the massive open online courses like edX or Coursera. There's a lot of information out there, both on the mathematics side, on the programming side, on the visualization side. So it's really a great time to be living in that. A lot of this data, a lot of these methods, a lot of the ways that we can manipulate data and get some really good actionable conclusions, it's all been democratized. It's out there. It's either free or it's pretty inexpensive, definitely compared to taking a college statistics degree. So with that, that's it. Mark, if you have any questions, now would be a good time.
Excellent. Thank you very much for that. Really enjoyed it. Yeah, so let's go straight into the questions. So you talked at the beginning about the 5 popular packages to install by default. How do you, well, I presume they are installed by default with Anaconda. How do I install additional packages?
Yeah, so that was maybe that question came in a little bit before the answer. But if it wasn't clear, you could use this conda package to do the install.
Cool.
From a command line, you can also use, as I said, SQL ML utils gives you another command line that is from a client focused, or you can use that SQL ML utils through Azure Data Studio now to do it graphically. So those 3 packets.
Excellent. So you mentioned a Python version that's installed, I think it's 3.5 something, wasn't it? Installed with SQL. Is that updatable?
It is updatable. It's a little bit trickier. It's updatable in your on-premises version. It's not updatable in your managed instance version. But if you're doing this on a VM in Azure, or you're doing this in an on-premise SQL, yes, it is updatable. There's some hoops that you'd want to jump through for that. But you may not actually need to do that at all. The differences are pretty slight between 3.5 and 3.8, 3.9. So you're probably not going to really need to jump through those hoops. Just,
okay, cool.
The biggest difference was jumping from Python 2 to Python 3.
Yeah, okay. Thanks for that.
You'd have to do it manually. I probably wouldn't recommend you do that unless you've got a very specific case for needing a later version of Python.
Okay, great. You mentioned just there, because this is another question. So is Python integration supported in Azure? So you mentioned it is in managed instance. Does that mean it's not in Azure SQL DB?
That's correct. It is not in Azure SQL database, but it is in Azure SQL managed instance, and it is in SQL on Azure VMs.
Awesome. You also covered this question. Presumably this Python code is running out of SQL Server process. I think the answer from one of your slides was yes.
Yeah, that's correct.
Another question, excellent, thank you for that. Another question about your code where Python uses indents or tabs. So in SSMS, does it really matter if you use tabs or spaces with your code?
It does. So let me go back to that example. Actually, let me find the example from the first demo. Yep. So note that all this code, it's within a text string.
Yeah. So
if I have a tab in there, that tab is within that text string. So that tab is going to be sent over to Python. Python's going to say, hey, I don't know what that tab means in this context. It's going to throw an unexpected character error, and it's going to stop the execution of the Python script.
So you're saying that for code blocks you'd use spaces then to
no, I'm saying you have to take that white space out completely. So Python would also interpret 4 spaces, I believe, as an indentation.
So does that mean that you can't do?
That's all, whether it's tabs or spaces.
Does that mean you can't do conditional logic then within this?
Oh no, I certainly could, but I would have to include the right number of tabs or spaces in that conditional logic.
Fantastic. Thanks for clearing that one up. So within SSMS, are the libraries visualizations, if a library provides them, supported, such as NumPy?
No, not within. Basically, I could create them, but not show. I could create them, but not show them, which is kind of unfortunate.
Yeah.
What I could actually, one way that I could do that is I could create the visualization, save it as an image. I could actually return that image, within a table of an image, a table that's just one image by one image, and kind of save it from there back into my database. So I could, save the image that way, but I couldn't view it from within Management Studio. I'd want to be using a notebook for that.
Fantastic. So that brings me quite nicely on to the next question. What are the practicalities of really doing this, the Python with SQL Server like this? Is there really any benefit of using Python this way as opposed to just connecting to a SQL data source via Jupyter or IDLE?
So the benefit is that I never had to leave the SQL ecosystem for any of this stuff. So I was able to embed all this Python logic within a stored procedure call, so I could use it in an SSRS report. So I could have Python logic, say, embedded in T-SQL that was part of my ETL process. That's another way to use that. I wouldn't have to figure out a way to orchestrate the Python. All this orchestration is managed for me by the SP execute external script. I don't have to schedule a Python job somewhere to suck data out and put data back somewhere else for SQL to pick it up. It's all self-contained in this one place. You think that answers the question, Mark?
I think so. I'm just wondering. So I guess it's the type of people that you see then using this. Do you think it will be more of a hybrid kind of DBA stroke, someone dabbling with data sciencey techniques against the data, or do you think data, hardcore data scientists would be using this technique?
Yeah, so what this technique is really for is for operationalizing the results of the data science process. So let's take my second example here. Is I had a lot of data about no-show rates in my organization, and I did some analysis of that data to kind of find a model that fit, a model that I could use to predict future performance. Once I'd found that model, and obviously I've simplified things here to say that the model fit, the binomial theorem. Once I found a model that fits, I can incorporate that code into T-SQL in order to kind of get the results in a report very easily. But all of my analysis and my data exploration, that happened outside of this integration. I'm in a notebook or I'm in PyCharm, which is my IDE of choice. But I could be in VS Code, I could be in idle, but notebooks are taking over. So I'm doing all of that analysis and exploration there. And only when I'm ready to, okay, this is the pattern that it fits, now I can operationalize it in my SQL Server.
Perfect. I think we'll wrap questions up there. We've got a sort of a final question, which you've already answered about. There's a few people wanting a copy of your presentation. You've already given that. What I will say to everybody is I'll hook up with Chris over email later, and we'll send when we start publishing all the videos for the past couple of weeks, we'll send out links to for the presenters' presentations and whatever, or you can just take a quick screen grab there. But we'll get that sorted to you guys, and you can maybe even hire Chris for doing something data sciencey for you as well, and hook up directly. I have to take commission though, Chris, if you get anyone hooking up with you.
Sure.
Right. Well, thank you very much, Chris. That was brilliant. I've learned a few things today.
Well, thank you so much for having me, Mark. I hope everybody enjoyed this.
Thank you. Yeah, I'm sure they did.